So hi everyone. Today we will be discussing about how to determine important nodes in a graph. So we'll be just going through the concepts and won't be discussing the cipher queries. For cipher queries, you can refer to this blog. The link is in the description. So the first and the foremost idea that is followed is popularity or a super spreader. So depending upon the degree, the node with the highest degree, that is having the highest number of connections in the graph, is considered as most important node. As this node can be the one once provided with an information can spread the information throughout the network very fast. The second idea that can be followed is the bridge or critical node. Like in the first case that we discussed, as a node having the highest degree is considered the most important. In case of bridging critical idea, the node might not have the highest number of connections but have critical connections. So let's understand by an example. Assume there is a city and there are some villages. Now there is a single road connecting the city to the villages. Now due to some issues, the road is now not accessible, for example. Then what will happen is that the city is deprived of some important agricultural of essentials, while the villages are deprived of some high-class medical facilities. For example, now this means that the road is very critical in this entire graph. This means that this graph, this particular edge, once broken down, leads to segmentation of the graph, and the other part becomes just inaccessible. So such nodes are called as bridge or critical nodes, and the idea is that such nodes are the most important nodes in some scenarios. The third idea being page rank. So page rank is something that I have already discussed in a previous blog and vlog as well. So it goes in the idea that the importance of a particular node is dependent upon the importance of the nodes to which it is connected. Right. Similarly, if you remember, in case of page rank, which is used for uh, ranking the search results in search engines, where when we have a URL coming from some page to a page X, determines the importance of page X. So here also the same thing is that, so the any edge coming from some neighboring neighborhood to a particular node determines the importance of that node. So its neighbors are determining the importance of a particular node and not it himself. We won't be discussing PageRank much because we have already discussed in a previous law. You can visit that. Now, PageRank can have multiple variations. The most important, like a few prominent ones being weighted or personalized PageRank. Here, what we do that depending upon the scenario given, we provide some weights, initially only to some particular nodes depending upon our choice. So initially, if you remember, like if you go through my previous blog where we start off with equal page rank for all the pages or nodes. Here, what we're doing is that we'll be assigning some higher values to some particular nodes or some lower values depending upon the scenario. Now, in case of the next one being article rank. In case of article rank, the idea is that any edge coming from a node which has which has a very low degree, so it has very low connections, and one of the connections is to a particular node. So in that case, such edges should be such nodes should be given more weightage. For example, if and there is a node X which has two connections. One is from node A and one is from node B. Whereas node A has a degree equals to 10 and node B has a degree equals to 2. So in that case, we should be giving more weightage to B because it's a rare node. Now, the next one being closeness. As the idea suggests that the most important node in such cases is the one which has the lowest average distance from all the other nodes. So if you have 10 nodes, its average distance to its distance from the average distance to each of the nodes should be lowest as compared to others. The formula for this is n minus 1 upon the sum of the shortest distance of u to all other nodes, as it makes sense. So we will calculate the shortest distance from a particular node u to all the other nodes. We will be adding that and dividing it by n minus 1 and then doing a reciprocal of that, so that the as if the value is the smallest, so the closeness centrality becomes the highest. So the node any node u which has the lowest average is given most prevalence and is considered the most important node. The last criteria being betweenness. So betweenness is pretty interesting. Any node which is the part of most number of shortest path existing on the graph is considered as the most superior node in case when we are following the betweenness ideology. So, for example, if we have say 100 shortest path possible in a particular network, and out of which a particular node A is part of 20 of them, and particular node B is part of 15 of them. So node A's importance should be higher than node B because it is a part of the shortest distance in most of the time. And it does make sense, right? Because eventually, if this node gets removed, it might be the case that the length of the shortest distance increases for most of the nodes. So, following this idea between is a node which is a part of the most number of shortest paths, it should be considered the most important.